Okay, section 3.7, implicit differentiation. What we have here, examples of functions. F of x equal cosine 2x, y equals sine 3x, divided by the quantity cotangent x minus tan squared x, quantity cubed. Notice they're given in terms of x. They have the form y equals stuff with x as the only variable. We can say that y is explicitly defined in terms of x. If I tell you what the value of x is, you can find the value of y. Put one number in, one number comes out. Functions. These guys are equations. If I give you the value of x, you can't definitively tell me what y is. You know, this one wouldn't be too hard. You'd give me two values that y could be, but you can't tell me concretely, if I give you x, what will y be? But there is an implied relationship here. So we say these equations give implicit functions, that there's an implied relationship. These can't be easily solved for y, and so we say that these equations are implicit functions of x. And even though there's only an implied relationship, we're still going to be able to find the derivative. But when we want to find the derivative when we're given equations as opposed to functions, we're going to use implicit differentiation. Now I'm going to try to explain what the cardinal thing that we got to remember to do here. The cardinal thing that you're going to remember to do is that every time you differentiate a y, you're going to follow it by dy dx. I'm going to try to explain why we're going to follow the derivative of every y with dy dx. Now, if you don't quite catch on to the reason why, that's not great, but you'll be able to still be able to get all the problems right. As long as you remember, every time we differentiate a y, we're going to follow it by dy dx. But now, the reason we should do this. When we find dy dx by using implicit differentiation, we will regard y as some unknown function of x. So we could really view y as y equal y of x. So say, for example, we were going to find the derivative of y cubed. Well, we could say the derivative of y cubed was the derivative of y of x, quantity cubed. And so look what you got right here. Right here, and we'll go over here to write my notes, we have an inside function of y of x and an outside function of that exponent of 3. exp stands for exponent. And so when I do this, I'm going to do a chain rule. There's derivative outside. There's derivative inside. And then just switching notations and getting rid of the of x, we end up with 3y squared dy dx. So when we differentiated y cubed implicitly, the answer came out to be 3y squared, what you really would expect. Derivative of y cubed should be 3y squared. But since y represents this implicit function of x, represents kind of this hidden function, to give the derivative of that inside hidden function, so to speak, every time we differentiate y, we're going to follow it by dy dx. That's my effort to try to explain why all these dy dx's will creep up. But here are actual steps. Steps to implicit differentiation. Note you will use implicit differentiation when you're given an equation as opposed to a function. 1, differentiate all terms on both sides. Differentiate the variable x as normal using all appropriate rules. Differentiate the variable y as normal using all appropriate rules, but after differentiating y, it must be followed by dy dx. Because we're viewing y as an implicit function of x, so there's kind of like this hidden inside function. And then the chain rule, every single time we have an inside function, you end up multiplying by the derivative of that inside function, which is that dy dx. Now a comment here. Note, neatness counts. You must make sure your x's look like x's and your y's look like y's. Some people prefer to use the y prime instead of dy dx, which is fine. But if you do, be sure you don't lose the prime symbol. Handwriting is an issue here. You misread your handwriting and get the answers wrong. Now, I won't punish you harshly for that on a test or quiz, but the computer Computer cares, and it's going to mark things wrong, so you got to be careful with your handwriting. So you're going to do a differentiation step using all your appropriate rules, and then you're going to do an algebra step. You're going to solve for dy dx and some basic steps there, clear parentheses, clear fractions, rewrite so all terms with dy dx are on one side, terms without dy dx are on the other side, factor out a dy dx, and divide both sides by any factor on the same side as the dy dx. So let's do this first problem. First of all, we're going to note it's an equation, not a function. And so we will use implicit differentiation. Now the homework, I believe the computer tells you each and every time to use implicit differentiation. I'm not likely to do that on a quiz or test. You need to recognize when to use implicit differentiation, and you're going to recognize it when you have an equation as opposed to functions. So now doing this, differentiate x, completely normal. Derivative of 4x squared, 8x. Differentiate y using the appropriate rules. So derivative of 9y squared would be 18y. But I just differentiated a y, so I get it followed by dy dx. And the derivative of 36 is 0. There's my calculus step. Now I solve for dy dx. So 18y dy dx equals negative 8x. And so dy dx equals negative 8x divided by 18y, or what? That's negative 4x over 9y. And there's my first implicit derivative. Started off with an easy one. Okay, next one's going to be more challenging. Find dy dx. Again, same thing. I have an equation, not a function, so I'm going to do implicit differentiation. Now I'm just going to rewrite this a little bit before we get started, just so it's a little bit bigger and emphasize some things. So that's still the original equation. And what I wanted to emphasize here is that that guy is a product. So we are going to start with a product rule. So starting with a product rule, plane first, derivative of the second, derivative of sine y would be cosine y, but I just differentiated a y, so it followed by dy dx. Plane first, derivative of the second, plus plane second, derivative of the first. Product rule. Plane first, derivative second, plane second, derivative first. Product rule. And that's why I said, using all appropriate rules. So coming up to the next guy, secant of xy. It needs a chain rule. So doing the chain rule, starting on the outside, derivative of secant is secant tangent. So secant xy, tangent xy. So I did the derivative of the outside, then the rest of the chain rule says times the derivative of the inside. So all of this right here is chain rule on secant xy, with the first part derivative outside, derivative inside. Now I've run out of room, so I'll drop down. I'll drop down on the next one. Derivative of 1 is 0, and then I've run out of room, so I'll drop down. Then I get that e to the 2y. Repeats, derivative of exponent, then I just differentiate a y, so dy dx. Repeats, derivative of exponent, and then I differentiate a y, dy dx. So there's my first sort of pass on differentiating. Now I still have a derivative to do right here. So let's keep working on it. Basically just copying this first stuff down, and trying to write small enough to get it on here. Then I come up to this derivative right here, derivative x times y, another product rule. So plane first, that's not the plane first. Plane first, derivative second. Derivative of y is 1, but I just differentiated a y. So it followed by dy dx. So there's plane first, derivative second, plane second, derivative of the first. So plane first, derivative second, plane second, derivative first. And all of that was a product rule on xy. So we're up there, I don't need the plus 0, and so then plus 2e to the 2y dy dx. There, all my calculus is done. I've done all the calculus I need to do, so now we're just going to start to solve for dy dx. So I'm just going to clean it up a little bit, getting rid of those extra ones in there. So just a first step of getting rid of those ones in there. So just cleaning it up a little bit. And so now I want to get that dy dx, and if you refer back to some basic steps over here, one of my basic steps was to clear parentheses. So that's what I'm going to do first, clear parentheses. And that is where I'll pick up on the next video.